My amazing students, this is Mrs. A, and tonight we're doing 7.4 of intermediate algebra, which is solving quadratic equations by factoring. And we're going to talk about the steps to factoring as we go along. So here I have a quadratic equation, and it is not in standard quadratic form. I can tell that it's quadratic though because I have an h times an h, which means I have an h squared, and that is the quadratic term of this equation. So a quadratic equation must have a quadratic term. And remember that the normal form, the standard form, is ax squared plus bx plus c equals 0. Okay, and we like to get an equation into this standard form of a quadratic equation when we are ready to solve, which means that we're always going to have a 0 on one side, and then we're going to factor this quadratic equation, and then we will set each one of its factors equal to 0. And remember, we do that because of the zero factor property, which tells us that if we have a product that equals 0, then either A is 0 or B is 0, or maybe they're both 0. So to find every single possible solution, we set them both equal to 0. And that's called the zero factor property. Sometimes it's called the zero product rule. But anyway, it's got 0 in the name. And it always means that when I have a product set to 0, I can find every possible solution by setting each part of the product to 0. Now let's look at the problem that we have here. We already have a product set to 0. So this one's already kind of half done for us. So we already have a product equals 0, so it's already in a factored form. So we're just going to set h equal to 0 and h minus 4 equal to 0. And now this is already a solution and makes the equation true. And this one I will add a 4 to each side and get h is 4. Yeah, solutions make equations true. So if I take a 0 and I plug it back in here and here, I get 0 times negative 4 is 0, and that's true. If I plug the 4 in here and here, I get 4 times 0 is 0, and that is true as well. So I have two solutions. Remember, quadratic equations generally have two solutions. Guess how many solutions a cubic has? Cubics have an x cubed term on the front, and they have 3 solutions. Quartics have 4 solutions, and so forth and so on. Now, on this one, I have a 0 on the other side, so this is already factored for me. It's half done already. So all I have to do is set 6a minus 1 equals 0 and a plus 5 equals 0. So then when I add a 1 to both sides, I get 6a equals 1, and a is 1/6, and a, when I subtract 5 from both sides, is equal to negative 5. So if you look, if you plug 1/6 into this portion, 1/6 times 6 is 1, take away 1 is 0. And this one goes to 0. 0 plus times anything gives you 0. If I plug in a negative 5 into this one, this becomes 0, and I get 0 times anything gives me 0. So I have my two solutions for my quadratic equation, and they both make the original equation true. Now the plot thickens a little bit. This one is not factored for me. But this is one of those easier to factor problems because notice I've got g squared. Well, since I've got a 0 on the other side, it's in standard form, so I'm just going to use that simpler factoring with g times g. Same sign, both positive, so I can go ahead and put in my plus and my plus. And then 21 only factors so many ways. Let's try the 3 times the 7. 3, 7, 3G, 7G, 10G. Okay, remember, factoring is just unfoiling something, isn't it? So I have a 0 over here, although I can't write 1 anymore. I've got this factor times this factor equal to 0. When I FOIL these back together, I get my original equation. When I set each factor equal to 0, I get G is -3 and G is 7. And those are my solutions, and they will each make the original true. If I take the -3 and I square it, I get 9. If I take the 10 times the -3, I get -30 plus 21 is 0, and it works. The same would be true with the 7. It also works. This is the first one that we have that is not already in standard form because there's not a 0 over here. However, we can easily put this in standard form by just subtracting the 96 from both sides to get a 0. Now, I would not do this problem like it is without first taking out a greatest common factor. Okay, so I look at all the factors and I say, you know what? Everything has a 4 in it. So I am going to, in fact, everything has an 8 in it. So let's pull out an 8. And I get a k squared plus a 4k minus, and 9 divided by 8 is 1. Carry the 16 over there, and then I get a 2. So 96 divided by 8 is 12. Much easier to factor because now this one is just a k and a k. And then I'm going to factor 12 in such a way that the difference will give me a 4. So I'm going to use 6 and 2. And I'm going to make the positive on the 6 and the minus on the 2. When I FOIL that, I get back to a -12 on the end. 6k minus 2k is 4k, and it is factored. So now this 8 is never going to be equal to 0. I really don't need to keep track of it because what I'm trying to do is set each factor that has a variable in it equal to 0. And we know by the multiplication property of equality that we can multiply both sides or divide both sides by the same non-zero constant. So I can just divide that 8 out and get rid of it. Okay, I can't divide by a variable, but I can divide by a constant. So now when I set this one equal to 0, I get a -6. I set this one equal to 0, I get a +2, and -6 and +2 are my solutions. They make the equation true. All right, so then we have one that's all messed up, okay? It appears to be factored on this side, but there is no 0 on the other side. So what we're going to do is distribute this out, pull it all over to the left, stick a 0 on the other end, and get it into standard form. So w squared is equal to 3w plus 8 times 3 is 24, so that's going to be 54. Okay, so then I want everything on the left, so w squared minus 3w minus 54 equals 0. So now I'm going to factor this equation. It's going to have a w and a w equals 0. And I'm looking for a product that gives me 54, but a difference of 3, and that would be 9 and 6. So I'm going to put 9 times 6 is 54. I'm going to make the negative on the 9, positive on the 6, to give me my inside, and my outside will give me the -3. So my solution, when I set this equal to 0, is 9. When I set this equal to 0 is -6. And 9 and -6 should both make that true. Let's just take the 9 and check it. 9, when squared, gives me 81. And 9 right here gives me 9 plus 18, which is 27, times 3. And 27 times 3 is 81. And it works. And I will be back with some more.